TypeScript offers significant advantages over JavaScript, starting with type safety and error prevention. By adding static type checking, TypeScript catches errors during development rather than at runtime. Type annotations make the code's intent clearer and help prevent common issues, such as accessing undefined properties. The TypeScript compiler can identify potential problems, like null or undefined handling, before the code is executed. Additionally, type checking ensures that functions receive the correct argument types and return consistent values, reducing runtime errors. Beyond error prevention, TypeScript enhances the developer experience. Features like robust autocomplete and IntelliSense provide accurate suggestions based on defined types, making coding faster and more efficient. Developers benefit from improved code navigation, such as the ability to jump directly to a function's definition. Inline documentation appears when hovering over typed variables and functions, offering immediate clarity. Refactoring becomes safer, as the compiler ensures type consistency throughout the codebase. IDE tooling also highlights errors in real time, eliminating the need to run the code to catch mistakes. TypeScript also improves code documentation. Types serve as self-documentation for function parameters and return values, making the code easier to understand. Interfaces and type definitions establish clear contracts between components, ensuring consistency. Type annotations communicate developer intent clearly to team members, reducing the need for extensive JSDOC comments. This makes the codebase more approachable, especially for new team members. Advanced language features in TypeScript further enhance its utility. Interfaces allow developers to define complex object shapes and inheritance patterns. Generics enable the creation of reusable components that work with multiple types. Union and intersection types provide flexibility while maintaining type safety. Enums create named constants that improve readability and autocompletion. Additionally, access modifiers like public, private, and protected help enforce better encapsulation. Refactoring in TypeScript is more confident and less risky. The compiler verifies that changes do not break existing code. Renaming variables and functions is safer, as references are updated automatically. When parameters are added, removed, or changed, the compiler highlights exactly where updates are needed. Type checking ensures that implementations match updated interfaces, making large-scale code changes more manageable. Finally, TypeScript maintains full compatibility with JavaScript. Since it is a superset of JavaScript, existing JavaScript code is valid TypeScript. This allows for incremental adoption, where types can be added to existing JavaScript projects over time. TypeScript can compile to different JavaScript versions, depending on browser support requirements. JavaScript libraries can be seamlessly used with TypeScript through type definition files, and the NPM ecosystem integrates smoothly with TypeScript projects. These features make TypeScript a powerful tool for modern development while retaining compatibility with existing JavaScript workflows. TypeScript offers significant scalability benefits for large codebases. By enforcing strict contracts through types, it makes the code more maintainable and easier to navigate. This clarity also improves team collaboration by defining clear boundaries between components, reducing misunderstandings. Developers working across different parts of an application experience less cognitive load, and onboarding new team members becomes more seamless. Additionally, TypeScript helps manage technical debt by promoting better code organization. However, there are some cons and considerations to keep in mind. Developers unfamiliar with static typing may face an initial learning curve. A build step is required to compile TypeScript into JavaScript, which can add complexity. In some cases, type definitions may become verbose and difficult to manage. For very small projects, the added overhead might outweigh the benefits. Furthermore, typing third-party libraries often requires additional setup, which can be time-consuming. On the tooling side, TypeScript boasts a rich ecosystem. Linters and formatters, such as ESLint with TypeScript plugins, help maintain code quality. Type-aware testing tools and frameworks streamline the testing process. Build tools like Webpack and Vite offer first-class support for TypeScript. And CI/CD pipelines can incorporate type checking as part of validation steps. Modern IDEs like Visual Studio Code provide excellent integration, enhancing the developer experience. For teams considering migration, TypeScript supports a gradual adoption strategy. The Allow.js compiler option enables mixing JavaScript and TypeScript files, allowing teams to transition incrementally. Developers can start by adding TS files alongside existing JS files and introduce type annotations as needed. The any type can serve as a temporary placeholder during migration, and tools like TS Migrate can automate parts of the conversion process, making the transition smoother.